Okay, so the idea here is you're on a ship and you found you're helping the captain navigate. And so you find that here are the commands available. Move north, south, east, and west. And I made a little compass rose here to help keep that straight. Then you can turn left by a number of degrees and turn right by a number of degrees. And then you can move forward. So you have to figure out where you end up. And so here's some steps. Forward 10, north 3, forward 7, right 90, forward 11. So what happens here is forward 10. Now the ship always starts pointing east. So the first direction it moves is 10 units east. And that takes you to location 10 east, 0 north. And east-west is what you might call the x-axis, and north-south is the y-axis. So to have an ordinary geometric coordinates, it makes sense to put the east here and the north there. So that's location 10, 0, assuming the ship started at 0, 0. Then north moves the ship 3 units north, so now it's 10 east, 3 north. F7 moves forward another 7 units, and we're still pointing east, so now we're at 17 east and 3 north. Our right 90 turns the ship 90 degrees to the right, so east turns into south. And now when we go forward 11, we move 11 units south. Now we were at 3 north, so if you move 11 south, you're now 8 south. You could also call that minus 8 north, another way to express the same thing. So these are the steps. And this, by the way, they want you to evaluate the Manhattan distance. If you're in a city, you can't go diagonal. You have to only go on the streets. So the distance is not the normal geometric distance between 2 points. It's the line along the horizontal and vertical streets. So it's the total horizontal distance plus the total vertical distance. And so they call that the Manhattan distance. So if you're at 17 east and 8 south, you just add those numbers together, 25 units. If you could go on the diagonal, it would be shorter, but in Manhattan, you could only go along the streets. That's the idea. So there's the problem statement. So this is a lot like the previous one. So we should be able to get a version of this working pretty easily. So give me some help. First, we got to get this data in there. How do you want to get it in there? We need that.
So you could copy and paste, or I guess if you wanted, you could try to scrape that from the website.
That's true. In principle, I could download this page and scrape them. Since there's only 5 of them, I think it's easier to just copy and paste. Like I say, the stupid answer is often the best. So I'm just going to paste it here, and then do a replace again. And I think it's still in my previous one, to replace a carriage return with quote, comma, quote, which is the essential ingredient. That gets me to here. And now I can just put a quote and a bracket, and a bracket and a quote. Okay, now I've got a list. So we'll start with that. And these are going to be steps equals that. Okay, so now I'm going to make a function called do step of step. There.
Step or steps?
Well, I don't want to pass in the whole array. I want to pass in one step for it to execute. Now, I'm going to have to store the location of the ship somewhere. So I think I need a global variable location. The location is going to be, it's going to start at 0, 0, which is east and north. And now, I'm going to want to refer to it in here. So I guess I could move it in as a parameter. It's probably the easiest thing to do. I could also declare it as an external variable. But that's, all right, so now, in order to do a step, I need, like last time, I need a series of if statements. So let's get the problem statement visible over here. All right. There's the description of what we have to do. So, for example, how do I implement moving north? How do I tell if I'm moving north? What should I put here, folks? Oh, let me get this smaller so you can see the instructions at the same time. There we go.
If n is in the element.
Yep. And you know what the elements are going to look like? Going to look like this. So it'd be the first letter. The first letter is always one letter. So how do I get the first letter? One of these steps. I'm passing in a variable called step that's going to be one of these. So that's step. And how do I get the first letter of a string? Call it out. What's that? Step what? 0. Yeah, step, square bracket 0. That's the first letter, okay. Now I want to know if that's equals n. What do you think of that?
Yeah.
You like that? Anybody see a problem? I was hoping you would. It's not going to work. That's going to assign the first letter to n. You got to do this.
Right.
To see that's the 2 equals to the condition. What that would do, in fact, we can run that. That'll be kind of, well, what it would do is it would try to assign the first letter of a string to n, but strings are immutable, so it will crash, and so you can't change the contents of a string. Anyway, so that'll tell me if the first character is north. Okay, if it's north, then what do I want to do here? Now up here, remember this location was east and north. That's what those 2 numbers are, how far you are east and north. So what do I do here to move one some distance north?
Then you're going to want to add the number to the assigned to the second,
Yep.
second number in the list.
That's right. So I would take location. How do I get the second one?
1.
Yep, bracket 1. Okay. And what's it going to equal?
It's going to have to. Well, would we just do equal, or would we do plus equal?
Plus equal is better. Very good. What do I add to it?
10. No, because we don't know. We don't want to assume that it's going to be 10 all the time.
No, we're passing in a number that might look like this, F10 or N3, any of these numbers. So we want to add the number part to it. So how do you get the number part out of that string? How do you want to do it? Yeah, that's it. Yep. Step 1, 1 comma. That'll get the everything after the first character. So is this going to work?
Isn't treating it like a string or like a number?
That's right. This is going to be a string. You have to make it a number with int. All right. Now I think we're getting somewhere. And I think I'll just stop at that point. That's enough. And now now we're going to put the stuff outside here. So it's going to be for s in steps, do step of s and location. And I'd like to print the location after every step, so I think I'll do it down here. Print s location. There. That should do it for those steps. And the only one I've implemented is north, but it should at least do the north, and it'll ignore all the rest. Let's run it and see how it looks. All right, we got a type error. Tuple object does not support item assignment. So that's rude. You can't, now this thing here is a tuple, and you're not allowed to assign one element in there. So how do you get around it when you can't change something inside here? We were not able to change this one element location. So how would you fix that?
Turn it into a list.
Yeah, go ahead.
Just change the parentheses into braces.
Good. I was thinking of something else, but this is a good idea. We'll just make it a list of 2 elements, and that's probably all we have to do. Let's give it a shot.
What was the other thing you were thinking of?
What I was going to do was make a new tuple. Take the elements of the old tuple, change them, and make a new tuple. But that's another way to do it.
It
This-
just gives you a lot of tuples.
No, it'll always be just 1 for the location. I just keep erasing the old one and overriding it. But anyway, this is more cool. Okay, so there we are. So now forward 10 doesn't work. North 3 moves by 3, and the other commands are not implemented, but it's working. And you just have to add more cases to your if to handle these other things like forward and rotate. But that's the idea. So you can make something that does this. Now, the reason why that one is actually very similar to the assembly code one we just did. The program is almost exactly the same. So it might seem kind of boring and pointless, but this is why I love the advent of code. Every one of them is like this. They start out with a simple one, and then they throw a twist in for the next step. So now, they say, here's what happens. And by the way, if you know anything about ships, this is true. Ships do not move on a Manhattan grid, and they do not move in that manner. That is not what happens at all. What happens is there is a waypoint which shows where you're going. And north, south, east, and west move the waypoint, which is just a mathematical object that you trace on. That's why they have, on the old ships, they had sort of a drafting table with a pencil, and you'd mark things, and they have a ruler and stuff. You figure out which direction you're going and how fast. That's what the waypoint does. So north, south, east, and west move the waypoint by this value relative to the ship. Left and right rotate the waypoint around the ship. and forward moves forward to the waypoint. So the ship actually moves on diagonals, of course. It's not restricted to north and south, east and west. So now it's very different. So if you consider these steps again, this is what they mean now. Forward moves, by the way, the waypoint always starts at 10 units east and 1 unit north at an angle. So the ship is at 0, 0, the waypoint is at 10, 1. And now north, south, east, and west move the waypoint, not the ship. But the ship only goes forward. Of course, they can't go backward. It only goes forward, and you rotate. So now this will move the ship to the waypoint 10 times. And the waypoint is at 10 east, 1 north, so the ship is going to move to 100 east, 10 north. And the waypoint stays at that location relative to the ship. You're still moving the same direction and the same speed. North 3 moves the waypoint 3 units north, so you turn the ship to point to 10 east, 4 north, which is a little bit north, not 90 degrees, but a smaller amount. Then you move to the waypoint 7 times. So you add 70 to east and 28 to north, and you end up here. Now R90 rotates the waypoint 90 degrees clockwise around the ship. So that if you are pointing to 10 east, 4 north, you'll then be pointing to 4 east, 10 south. Mathematically, you take the second parameter and move it to the first, and you take the first parameter and take the negative and move it to the second. And that I found a little confusing, but I figured it out, and it helped to have this little diagram to figure it out. That's what 90-degree rotation does, and now you move forward 11 in the new direction. So you end up moving a much larger distance, 286 units. And by the way, this is still a Manhattan distance, just because we're measuring it in that matter. You just add the east-west motion to the north-south motion, but you don't, in fact, that's just a way to get a final answer for a flag. So this is what's very fun. I mean, you get a simple problem going, and then they change it, and you have to reinterpret it, and that's often more interesting. So that's what I wanted to show you, and I make the second part extra credit. And I'm trying to make it so you only really have to do the easy part, but the extra credit is there for those who are ready for it. So that's what I wanted to show you. Let me check and see if there's comments in the Twitch. I can find the demos online on the website. Yes, they're going to be here. This is a common question. Everything I do in class is recorded and put on YouTube, and you'll find them up here in the calendar of the class, and I'll throw this link in the Twitch in case there's somebody here that doesn't have it. Yeah, that's where all the videos go, so you can review things. And like I say, you might want to, if you get stuck, this will show you one way to do it. All right, good. Well, that's what I wanted to show you. I'm going to stop this recording.